All right, so today we're going to talk about 10.5, which is independent and dependent events. So right now, make sure you have your math composition notebook out and you are taking notes on everything we are doing. So first, the learning target is going to be, I will be able to find the probability of independent and dependent events. Once you have that written down, we will move on. So the first thing we're going to talk about is independent events. If something is an independent event, it means that the occurrence of one event does not affect the likelihood that all the other events will occur. Okay, and this is what you are going to want to write down. P, the probability of events A and B, equals the probability of event A times the probability of event B. Okay, and again, if you have more than one event, if you have 3 events, it's just that same formula over and over again. So you're going to multiply the probabilities of each event together. So you need to have this down, write down this equations, and then you may move on. So let's talk about independent events. So if it says you spin the spinner and flip the coin. What is the probability of spinning a prime number and flipping tails? So these are independent events. What I spin on the spinner has nothing to do with whether or not I flip a heads or tails. So here is how we are going to set it up. So first, I'm going to find the probability of spinning a prime number, okay? And what we need to know what our prime numbers are. So I know that 2 is a prime number. I know that 3 is a prime number. And I know that 5 is a prime number. Okay, so I am going to write a 3 on top because remember, if I want to find the probability of spinning a prime number, I need to put how many ways that it's possible to do that. And then on the bottom, how many numbers there are total. And that is 5. Okay, there are 5 numbers total. So let's write this down because there's 3 prime numbers. And then this is because there are 5 numbers total. And then now we're going to find the probability of flipping a tails. So that obviously is, well, it's either going to be a tails or a heads. Therefore, the amount of tails you could flip is 1. And the options that you have is 2. Okay, and that is because there is 1 tail side and then there is 2 sides total. All right. So now we're going to write our equation, which is the probability of events A and B, which is the probability of events prime and tails, both of those things happening. And so we are going to multiply the probability of spinning a prime number times the probability of flipping a tails number. And we're going to just fill it in. So the probability of spinning a prime is 3/5 times the probability of flipping a tails is 1/2. See, can I cross cancel? Nope. So I'm just going to multiply those together. Numerator times numerator, that gives me 3. Denominator times denominator, that gives me 10. So my answer is 3/10. And if I want to get the actual percent, all I need to do is type it in my calculator, 3 divided by 10, and then turn it into a percent. And that is my answer. All right. So that is how we are going to work with independent events. Make sure you have this written down. Then we're going to move on. So dependent events now. This is just the opposite of independent events. And it means that the occurrence of one event does affect the likelihood that the other events will occur. So write this down, please. The probability of events A and B, and it's the probability of event A times the probability of B after A. And I'm going to show you how that works on the next example. But make sure you have the formula down and what dependent event means, and then you may move on. Okay, so here's how it works. Finding the probability of a dependent event. So people are randomly chosen to be game show contestants for an audience of 100 people. So that means the audience is 100 people. You are with 5 of your relatives and 6 other friends. What is the probability that one of your relatives is chosen first? And then one of your friends is chosen second. So again, that second event is going to rely on that first event. So let's talk about what we're going to do. So first, let's find the probability of them choosing one of my relatives first as the first member. Well, how many relatives do I have? I have 5 with me. Okay. Out of how many people are in the audience? Well, there's 100. Okay, wait, let's reduce our fraction. Divide it by 5, divide it by 5, and that's going to give me 1 over 20. And just remember, this is because there are 5 relatives, and this number is because there are 100 audience members. Okay, so we have the probability of choosing a relative. Now, let's find the probability of friend chosen second. Okay, so friend chosen second. And that's going to be, well, how many friends do we have? 6. Okay, so we have 6 friends over how many audience members are left. Now, here's where the dependent events comes in. We had 100 audience members, but it's asking for the probability if the friend is chosen second, which means that somebody has already been picked, which means we no longer are choosing from 100 people, but we need to take away 1, and it's going to be 99 people. Okay, and that's because there are 99 audience members left. Okay. Now let's reduce it. I could divide both these by 3, and that would give me 2 over 33. Okay, now we're going to find the probability of the full A and B. So probability of choosing a relative and then choosing a friend. And what we're going to do is that's going to equal the probability of choosing a relative first times the probability of choosing a friend after relative. Okay. Now, the probability of a relative is 1 over 20. So we're going to write that times the probability of choosing a friend after the relative is 2 over 33. We want to look at this. And remember, for multiplying fractions, you want to see, can I cross cancel? Well, I know the 20 and the 2, I could both divide by 2. That would give me 1 and 10. Then from there, you're just going to multiply numerator with numerator. That's going to give me 1. And denominator times denominator, 10 times 33. That's going to give me 330. If I go in my calculator and I go 1 divided by 330, I will be given a decimal. I'm going to turn it into a percentage by moving the decimal point 2 places to the right. And that's going to give me 0.3%. So those are your options. Those are the probability of choosing one of your relatives first and then choosing one of your friends second. Okay, so that is independent and dependent events. Make sure you have these notes written down, and then we will start the Big Ideas assignment soon. Thanks for watching.